I apologize for all this, for 16 minutes of technical issues that I experienced. When you join, switch off your video and mute yourself. And today's session, we're only going to do chapter 1 and chapter 2. And these are the topics that we're going to be discussing today. We'll just run through the basic concept. It will be quick, and then we'll look at the types of variables. There will be some exercises on there as well that you are able to engage with and do them, and they will just prepare you to be able to do your assignments as well. And I don't think we will take a 5-minute break now because I've wasted 20 more minutes. So we will just continue straight through, but I will see, we might have 5 minutes break because it's not useful to have an longer screen interactions. So we just need to always pop away from the screens, and then we will end up with the visualization. If we don't finish, it's fine. We can also start again on Friday where we left, on Saturday where we left off, and then do the rest of session 3 on Saturday. Okay, so we're going to start with the basic concepts of statistics. When I realized my mic was muted, I asked the question, can anyone tell me what do they think statistics is about? And do they know which areas use statistics in everyday life? On almost every day we hear about them. So can you give an example as well when you explain if you know what statistics is about? Just 1-2 people, just to gauge the understanding. What do you think statistics is about? You can unmute yourself and say it out loud. Nobody?
I'd say it's the measurement of data.
Is there? Sorry?
Measurement of data.
Measurement of data. Okay.
Yes, very simplistically.
Okay. Others? Nothing. Okay. So since there is nobody who wants to say, let me unpack statistics for you. So by the end of 30 minutes, or now it's going to be by the end of the last 15 minutes that we have on this, you should know what statistics is, what are the concepts that we use in statistics, and you should understand the types of variables and the different levels of measurement. And later on, we will look at the visualization of these variables that we're talking about. Okay, what is statistics? So statistics is a way where we get information, which is data that lies in multiple sources of information somewhere on Excel spreadsheet or in the databases or in our CRM systems. And we take that data, we enrich it by doing some calculations, by putting it in, calculating some averages and so forth, and then visualize it in nice tables and charts and forms and present it so that people who make decisions can make informed decision based on the data that they see. So in a nutshell, statistics is a method where we transform data into useful information for decision making. And that's all what statistics is about. Why do we study statistics? So let's say we want to develop an appreciation of variability and how some products are affected by the price changes and so forth, or if we want to improve the processes, or we want to invest in more systems or improve the systems that we have, then we can use statistics to help us with that. We can also use it to estimate the present and also predict the future, which means we can forecast, like you can see now with the coronavirus, where people are like they're talking about what the data for today, but they can also tell you that they predict or they forecast that the numbers will rise or the numbers will drop or things like that. And that's part of what statistics. The areas, they are very different. Some people do statistics in econometrics, some people do it in biostatistics, some do it in so many areas. For example, I work in the business intelligence department at the university, so I use statistics on my daily basis to help the executive to make decisions. We use the present data and we use the present data to forecast or predict the future. We want to know how many students we want to grow the university with, how many amount of students. We use statistics to create those forecasting models. We use statistics as well to understand some basic ideas of the statistical reliability and stochastic processes, which include also calculating some probabilities and chances to see what's going to happen in the future. For example, what are the chances that when we open up, I'm going to use coronavirus and the lockdown processes. What are the chances that when we open up the alcohol and tobacco, that the numbers of cases of coronavirus will rise? All those things, they are put through some of these cases where they test them and they check the probabilities. We use statistics also for very important, or statistics is very important in every aspect of the society, including government, businesses, even in our daily lives. So we can, if you know statistics, you can apply it in your everyday life. You can even calculate the average amount of money that you use on grocery over the years, so that you can improve on maybe reducing on some of the things that you don't need and buy the things that you really have to buy. We can use statistics to do a lot of things. And mostly statistics, we use it to solve problems, because if there are problems, we can use statistics to solve them. But it doesn't solve problems, it just highlights the areas of concerns so that the decision makers can make changes so that they can solve those problems. Like we define statistics as we take data and we turn it into information in order for us to build new knowledge. So you can build totally a new knowledge out of statistics or out of the data that you collected. Where do we use statistics on an everyday life, and why is it important? We use it also to cure diseases. So for example, like with the coronavirus, we can predict where the virus is going, where it comes from. We can check and test the data and do the confidence levels and do the prediction about the coronavirus. We use statistics in politics as well. So if we want to know, people run surveys during the election to see which party might win the election, and this can sway decisions. People make decisions based on what they see or observe. So with statistics, once they put it out there for people to engage with, then people can make up their mind about which party they will prefer to choose, because they can see the majority of people are going to choose that party. So we can use it as well to influence ideas and decisions. We use statistics as well to forecast the weather. So when they say, so these are people who work in the weather centers. So they use statistics to predict whether there will be rainfall and so forth, or whether it's going to be cold or the cold front is coming, and what is the percentage of the wind that is going to come and so forth. So that is statistics. It's very important. So if you know this and you can use it on your day-to-day basis, it means you can solve as many problems as you can. So While we talk about statistics and we're talking about summarizing the data, therefore it means we need to understand that with statistics, we are able to describe data. And when we describe data, it's data that we would have collected. So therefore, there is a branch in statistics. So you will see, we will be discussing two things. We will be discussing one branch, which is the descriptive statistics, and we will also going to discuss the branch which is called the inferential statistics. With descriptive statistics, it's a method where we collect data, we summarize the data, and we collect it via surveys, questionnaires from the CRM systems, and then we summarize it by using tables and charts, or even the measurements, like calculating the averages and the medians, and we calculate the standard deviation and the variability of your data, how far apart your data is from the mean. Then the other part of statistics is your inferential statistics, which talks about the inferring your data to the population that you are studying. So making decision about the population you are studying from the sample. And we use, for that purpose, we can do the estimation, where we estimate what will be the appropriate population weight that we can assign. We can also use what we call the hypothesis testing, where we test one view against the other. So we might say, we know that the average mean of people who get infected in the Western Cape is 300 per day. And we can do a hypothesis test, which will say the opposite of that. That will say it's not true. The average number of people who get infected or who get coronavirus are less than 300 per day. So we use hypothesis testing for that to test. And like I said, we infer back the result to the population. It's just by using all this other method, we draw the decision about the large population that we would have collected data from a smaller group, which will be your sample. Okay, so once you understand those two key concepts of your branch of statistics, which is your descriptive statistics and your inferential statistics, you also need to understand, because I've raised some of the things there. I've talked about the population, I've talked about the sample. What do they mean? What was I talking about? So a population is a set of all elements or items to be studied. So everybody. So let's say I want to study South Africa. Everybody who stays in South Africa, whether you are foreign or you are here as an asylum seeker or you are here as a South African and so forth. As long as you are in the boundaries of South Africa, you will be part of my population. And because I want to study what's happening in South Africa. But since it is so huge and it's very expensive to study the whole population, it is best to select a subset from the population. And that subset, we call it the sample. Before I move to the sample, when I select the survey, or let's say, for example, the census. Census is the study of the entire population of South Africa. So when they do the census, when they collect information from the people, they ask questions. Who are you? Where do you stay? Those kind of questions. Do you have water? Do you have electricity? Do you have a flushing water, toilet? Do you have this? All those things. When they ask, after they collected that information and they go and they start summarizing the information when it comes to analysis, when they calculate like the mean, the standard deviation, and the variance, they are calculating what we call the parameters. Those are the measures that are used to describe what is happening with the population. And we call those the parameters. So since the population is so big and we cannot calculate the parameters for every individual person in South Africa, therefore we select the sample. And a sample is just a subset of your population. It's just a small group. There are techniques that are used, because sometimes you need to use a probability sampling method, which means the data that you select from the population, you can infer back your results to the population. Sorry, the data that you select from your population, and you create a sample, you do the analysis, you should be able to infer back those results to your population. But if you use a non-probability sampling method, which like which is like convenience sampling and so forth, you cannot infer back the results. That will just be an opinion about the sample that you have selected. Lucky enough, in your module, you do not have to worry about the process of selecting a sample from a population. All you just need to know is what is a population, what is a sample, and also what are the measures that you select from the population that are called statistics. So when you calculate those means, the medians, and the standard deviation, we call those measures statistics. So those are the key concepts that you need to know about what the population is and what are the measures that comes from the population, and what the sample is and what are the measures that comes from a sample. Okay. Do you have any question? I know that I said we're going to be interactive, but it feels like I am talking too much. Okay, so if there are no questions, if everything is clear, then we can move forward. Okay, and that is your exercise. Since everything was clear, there is your exercise. I'm gonna give you only 2 minutes or 1 minute to think about it, and then we're going to have a discussion about it. So, in a hospital, 7 randomly selected patients have the following blood types: O, A, B, B, A, O, O, and A. So those are the blood types. In that case, identify what is the population from that. After you have identified what your population is, identify what your sample is. You have 1 minute. Okay, you can unmute yourself if you want to give an answer. What will be the population of this study?
So the population is 7 and the sample 4.
And anyone who wants to, do you agree? And if you don't agree, what is your option? Anyone? She's saying the population is 7 and the sample is 4. Do you agree?
No, so the population would be everyone in that specific hospital, all the patients in that specific hospital, and the sample would be the 7 randomly selected patients.
Population is all patients, and the sample will be only 7 patients selected. And that's how you define your population. Remember, the population is it's all elements of interest. It's everybody in the hospital. So it will mean all the patients. So because here we're talking about patients, so it will be all the patients that are admitted in the hospital or that are in the hospital, and the sample will just be only the 7 that were selected. As long as you see a word randomly selected, that means they have selected a sample. Okay. Any questions before we move to types of variables? And we are right on time. Okay.
None for me.
If there are no questions, remember, if you're getting lost and you don't understand, this is your chance. Remember, on my UNISA, we can't even talk. So this is your chance to raise your voice and say when you are lost. Because this is the only opportunity in your lifetime that you will receive that UNISA allows us to do online sessions, because usually they don't allow this. Okay. When we continue with the key concepts, we need to understand the types of variables. So when we recap on what we did just now, we spoke about the population and we said we select things from the population and we measure that, and those things, when we measure them, they become what we call the parameters, or we even go and select them from the sample and we measure them and then they become statistics. What are those things that we're supposed to be collecting in order for us to measure? And those are the things that we're going to be discussing right now. A variable. A variable is a characteristics that describe an item or an element or an individual. And a variable is something that you can observe or you can measure. For example, I said you can go and collect surveys about, or let's say the census. So when they collect information and they ask you, how old are you? That is a variable. It describes how old I am. If they ask me, are you a female or a male? It's a variable called gender. They're going to ask me my gender. These days, we no longer even talk about gender, we talk about sexuality, because there are so many sexuality. People identify themselves differently these days. So they will ask you about your sex, and you can say, I identify myself as a female or a male or a da-da-da or a da-da-da, those kind of identification. Those, when we talk about sex or gender or income group, those are variables because they are characteristics that define an item or an individual thing. If I buy a pen, that pen, if the color of that pen is red, that color is a variable because it describes the type of a pen that I'm buying, the color of a pen that I'm buying. Okay. Then, for example, I've been saying you ask me my sex or my gender, then I tell you that I'm a female or I identify myself as a female. The minute I say I'm a female, that is a data. It's what we call a data point. And a data is a set of values that are associated with a variable. Remember, a gender will just be your variable, and the value that goes with it, with the variable, will be either a male or a female or something like that. And that is what a data is about. For example, like with the color of a pen, a color, whether it's black, green, red, those black, green, red are what we call data. And that's the thing that we summarize. We use data to summarize the information. Okay, so since we spoke about the variable, we defined nicely what the variable is. Like we said, the variable is gender. We need to also understand what is this gender, what type of a variable it is. Is it measured or is it observed? Remember I said a variable can either be observed or it can be measured. So yeah, we're going to unpack that. So there are different types of variables that we get. we can get a categorical data, a categorical variable which produce categorical data. So you will constantly hear me interchange the two. So a categorical variable is a variable that can be placed into categories. And we can also call it a qualitative data because of the quality part of it. So it defines the quality, which means the color can define what quality of a pen is this in terms of the color. Oh, let's put it in a nice way and understandable way, a category, because we can categorize the color of the pen in terms of if I have lots and lots of pens, I can group them based on their color. So I can put them into the color category like that. Then we also have what we call a numerical data. And numerical data is data that can be measured or can be counted. Numerical data can be measured or it can be counted. And we can also call the numerical data a quantitative data, a numerical variable. We can call them numerical variable or numerical or quantitative variable. I'm used to using quantitative data, qualitative data. Now I must talk about variables so that we don't get confused as well. So a numerical variable is data that is variables that you can count or you can measure, and we call them quantitative variables. The variable that can be counted, like how many number of children do I have? I can count the number of children. I don't have a half a child, I have a whole child, so I count them. There will be 1, 2. As long as a value can take a whole number, it is a discrete value. Only if the value or if the variable or the data point is a whole number data point, then it is a discrete variable. If it's a whole number, it's a discrete variable. If the variable contains data points that are decimal in nature, then we say we are counting them because we can use a measuring tape to measure the height. We cannot count how tall you are. We can measure you by using the tape or the measuring scale. We can measure the temperature. While we still at that, so continuous data is data that we measure. Discrete data, data that we count. So discrete, how many number of children do I have? I can count them. Continuous, I need to get the measuring tape to measure my height, or I need to get a scale to measure my weight because I cannot count. Now, for discussion, what about age? Who can tell me what age is? Is it a discrete or is it continuous? What is the variable age?
It's continuous.
Why?
Well, because like you can measure age in like days or weeks or months or years. Like,
thank you very much. Yes, because if you are a female and you already gave birth to a child, you will know that when your child is born, they tell you, oh, you have a beautiful son was born at 12:06. Therefore, it means already your child was born in a continuous variable manner. He was not born at 12 o'clock, which is just a whole number. He was born at 1206, which contain they are just so lazy to also capture the seconds, because then I don't know at what second do they record, but they record the minute that the baby is born and say, yeah, what's crying, and then they record that the baby is born. So they record the minute, the hour, the minute, and the second. So your age is continuous. And there is your other exercise. Since we understood what types of variables are, now same exercise that we had previously in terms of the data, you need to identify here what the variable is, you need to identify what the data is, and you need to identify whether the data that you or the variable that you have identified, that you have identified, is it numerical or is it categorical? You have 1 minute. It's not going to take you long. Okay, you can unmute and let's have a discussion. What is a variable? I'm not muted, so what is the variable?
I would say it's categorical.
No, I need to know what the variable is from here.
Oh, the blood type?
The variable is blood type.
Type.
Wait, sorry, I just realized something. Is the meeting recording? I am there. Okay, so it's recording. And what is the type of data? What is the data?
The data would be the 7 patients.
No, the data is those.
The
values.
blood groups.
The blood groups, the O, A, B, B, A, O are what we call data. Remember, the data is the values that are associated with the variable.
Okay.
Then, if we know what the data looks like, what is this variable? Is it numerical or is it categorical?
Categorical.
It is a categorical data because we can put it into categories by grouping the blood together. We cannot, numerical data, we can apply the mean, the median, we can summarize it in that nature. Whereas categorical data, you cannot calculate the mean, the median, and the standard deviation and so forth. Okay. So number 2, which then will lead us to that 5-minute break. Which of the following variable is not a categorical variable? You have height of a person, gender of a person, achievement of score or achievement score of grade 12 learners as high, average, and low, choice of whether the test item is true or false. Just look at that, and then we will go through each statement and identify the type of variable for each statement just now. Okay, so let's go through each statement. So the first statement, is this categorical or numerical?
Numerical.
It's numerical because the height, you can only measure it. So this will be a numerical data. And the second one?
That's categorical.
Categorical.
We will get back to our question just now. This is categorical. And the next, achievement of scores as high, average, and low.
Categorical.
Categorical.
Categorical. When you look at the first part of the question, it says achievement of scores. Usually, your score will be a numerical, but because of the added information that extends, it makes this a categorical. Sorry. Categorical variable. And the last one, the choice of the weather, a test item is true or false. It's also categorical. So you can see which one is not. Therefore, it means our number one is our correct, incorrect answer. Which of the following variable is not a categorical variable? It will be the height of a person.
So in terms of the descriptors.
Oh, wait, sorry. Let's say ladies first.
Okay.
Yes,
sorry.
Ask your question. Yes.
So in terms of the descriptors of your variables, is it always either categorical or numerical? So it's always an option of those two?
Yes, it will either, they will either say categorical or numerical. But remember as well, at the later stage, you will see we will be adding the levels of measurement. So they might say numerical, discrete variable numerical, or remember as well, they might also say not only numerical, but they can call this a quantitative data. Remember that, ne?
All right.
Remember that it can be a quantitative data. They can interchange the two words. For categorical, they will say qualitative data or qualitative variable. So they can use either one of the words. Okay.
So are you saying your qualitative is also categorical?
It
And then
means
your numerical is quantitative. Okay, all right,
yes.
Got you.
Okay, and the gentleman, you were asking a question?
Yeah, I wanted to ask a question about but you touched on it when we were talking about the levels. I wanted to talk about the numerical part, the first one, whether it is a discrete or it is a continuous. But you said we were going to look at it.
Aha, that's what we're going into now.
Thank you so much.
Okay. So now, since we understand the two variables, qualitative, quantitative, or qualitative categorical, quantitative numeric variables, let's understand the levels of measurements. Since we said categorical data is data that we can put into categories. Data that can that does not have an order or rank, we call it a nominal level of measurement. So for qualitative data or categorical data, there are two scales or two levels of measurement. And here as well, you will hear me talk about scales of measurement or levels of measurement. They interchange them. So sometimes they say scales of measurement, sometimes they will say levels of measurement. So for categorical data, we have two levels of measurement. We have a nominal and ordinal. So for the nominal data, it's data or nominal variable. It's variable that can be placed into categories, but it does not have a logical order or rank. And you cannot use it for calculations where you calculate the median, the standard deviation, and so forth. It can be used in comparison because you can compare amongst the group to see how many males and females are in that group. You can use it in that manner, but not in a mathematical comparison way. Like I just already gave an example, like gender, race, there is no order. Political affiliation, there is no order on which one is higher than the other. There are so many other types of nominal data out there, like types of cars, or the manufacturers, or the type of cell phones, or the manufacturers of cell phones, or something like that. So they are different. So you can own a Nokia, Samsung, an Apple, like that. There is no order. Okay. Then we have another type or another level of measurement, which is an ordinal. It's also a categorical variable, and that variable, it has an order or rank to it. For example, if you walk into a bank, they always have those service teller rank my services thing there, and they ask you to rank from 0 to 1, or when you call DSTV, sometimes they will say hold for the survey at the end of the call, and they ask you, can you rank the operator that helped you from the level of scale from 0 till 10? Because it talks about 0 being poor or not being able to help you, and 10 being excellent. So there is an order in which you rank that level of service, and that is an ordinal scale of measurement or level of measurement. Similar to nominal, you cannot use it in any calculations, but somehow, some way, we try to use it to compare things. So, but in your first level module, you just need to know that you cannot use it in any calculation. You cannot calculate the mean, the median, and the standard deviation. But you can use this as well. So this one, you can use it to compare, because you can compare and see how people have answered. Do they answer the highest on the favorable scale or on the lowest favorable scale? Things like that. And you can put it in order, because you can order them from 0 till 11, which means if it's a 5 scale, maybe possibly they're asking you if you agree or disagree. They will say strongly agree, and don't know, disagree, and strongly disagree. And you can rank them, and when you visualize them, you also put them in that order. And we can use this in so many other things, like the dress size, like level of satisfaction, education level, or even your rank at, or the position at work, they are ranked, or the salary scales, they are ranked, things like that. And those are, actually, when I move to, to salary scales, which are ranked, maybe you are in A or B or C or D, something like that. Some companies use letters, some they use numbers, the peronomous scale. Those you can put them in order. So we call those ordinal. And this is only for categorical data. For numerical data, we have 2 scales, which sometimes interchangeably, there is one scale that doesn't feature at all. But for the purpose of your module, there are 2 scales, which is the interval and the ratio. For interval levels of measurement, it's an ordered scale, which it shows the difference between the 2 measurements, and the measurements have a meaningful quantity, but it does not have a true 0 point. What do I mean by that? I'm saying it does not have a true 0 point. For example, there are only 2 or 3 things that can be categorized in terms of interval scale. Since they do not have a true 0 scale or a true 0 point, it means 0 is just another number. Temperature. So how hot it is, when you look at the temperature can go into a negative degrees. So like I said, there are very few that uses this that you can assign an interval scale to. Temperature, your bank balance, where it goes into is it debit or credit, where it's negative. What else goes to negative? Does the sea level goes to negative? When you are above ground, it's positive, and when you go down sea level, it becomes a negative number. I don't know. So any number that, any numerical value that can assume a negative and a positive value, it does not have a true meaning of a zero, because zero is just another number, like any other number that define that it's cold when it's a temperature, things like that. And the other measure or level of measurement is what we call the ratio. And a ratio, like with the interval, you are able to calculate the difference between the measurement, because you will get a meaningful answer from there, because you can calculate the distance between home and the church, or home and school. You can calculate that distance, and it has a 0 point. The meaning of a zero is there, because if, for example, you traveled zero distance, it means you didn't travel, you didn't move, you haven't gone anywhere, you didn't travel. So zero means nothing, like you don't exist, it doesn't exist, it didn't do anything, it didn't become. And that is the true meaning of zero that we're talking about. For example, like which value can have a true meaning of zero? So your weight will have a true meaning of zero, because if your weight is zero, it means you don't exist. Nobody can have a zero weight. Your height cannot be zero, because then it means you also don't exist. Or a building cannot have a zero building, therefore it means it was never built, doesn't exist. Your age cannot be zero, because then it means you never existed. So, things like that. So those that have a true meaning of zero, we call them a ratio. So you should know the difference between the two and how to classify the two variables in terms of the levels of measurement. Okay, so now I'm going to flash the statement. Anybody can say what that statement is. We don't have to discuss it. We don't have to worry about discussion. So I'm flashing it, and then you say it's nominal or ordinal. Since we understand what nominal and ordinal is, categorical data takes a form, level of measurement of nominal or ordinal. Nominal, no order or rank or natural law. Ordinal, there is an order or rank. Interval and ratio are categorical or quantitative. Interval, there is no true meaning of zero. Ratio, there is a true meaning of zero. It means zero means something. Zero means you don't exist. Okay. Weight of a watermelon in store. Is it nominal, ordinal, interval, ratio?
Ratio.
You can unmute. It's a ratio.
Ratio.
The ratio. Time of day, when it's morning, after, evening, night.
Nominal.
When it's morning, evening, night.
Interval.
Remember, time of day. Is it a categorical or numerical? It's categorical. Categorical, it takes only two values, nominal or ordinal. So this is ordinal, because you start in the morning, it goes to the afternoon. There is an order of how the day proceeds. So this is ordinal. Because there's an order there. Distance from your place to the nearest 5 grocery stores.
Ratio.
It will be a ratio.
It's a ratio. Airplane companies serving at a given point.
It's nominal.
It is nominal because the airline companies is like Safair, BA, Kulula, Mango, SAA. So there will just be a nominal. Okay, so any question while we have 15 minutes to complete what I need to do? So I'm going to ask and plead, can we extend our time since we ran into problems so that we can finish today's session? I think by 2:15 we will be done. 8:45 we should be done. Silence means you agree with my statement. We will finish at 8:45. Thank you.
Yes, we do.
Yeah, I'm fine with this.
Such a wonderful group. The places in a ranking of chess players, first, second, third, and fourth, and
Ordinal.
so on. This is ordinal. Okay. Any questions? Then we go into visualization, which is organizing data. Okay, if there are no questions and you are happy, we can move into visualization. We will start by looking at how do we visualize qualitative variable, because it's easy with that. In between the slides, I have some exercises. I might skip those exercises so that we are able to finish, but you will have an opportunity to go onto my UNISA to do lots of exercises that are based on the content that we have, especially on study unit 1 and study unit 2. I'll open it up today. Actually, when we're done, I will open up study unit 2 as well. So by the end of Q2, you should be able to know how to visualize or construct tables and charts for numerical data and also for categorical data. So since we know what categorical data is data that we can put into categories. So if it's something that we put into categories, there are very few things that you need to know in your module. You can either create a frequency table, which is also called a summary table. We call it a frequency table. It can also be called a frequency tabulation or table. Or you can create a graph, which can be a bar chart or a pie chart. You do not have to worry about the Pareto. In your module, you don't learn what the Pareto is. So those are the only 3 things that we're going to cover now. So visualizing categorical data, a summary table looks like this. It's just a table that shows you the categories and show you the percentages. It just indicates Either we can use percentage or we can use frequencies or count. So we can also create a frequency or count. And you don't even have to discuss anything. So in your module, they don't expect you to discuss or explain what 38% means. So all they just want to know is, do you know the properties of the table? Do you know that you can only use categorical data to create a summary table? And a summary table is made up of categories. So your categorical variable, which makes of categories, and you can use the count or the percentages. That's all you need to know. Like I said, there will be some exercises in between. I am just going to do the exercises for you. So let's say in the exam, for example, because I didn't explain how you get the categorical, how do you get the percentages? So in the exam, they give you this table and they ask you, because these are frequencies or count, they ask you, what is the relative frequency? Relative frequency, what they mean, it is what is the percentage. Therefore, it means you have to calculate the percentage of this table. Calculating the percentage of this table, you need to create a total column. Oh, come on. You will create a total column. So in the exam, you will go as quick as possible because you will want to answer the question as quickly as possible. But for this purpose, so we go and we say 160 plus 246 plus 94, and we say it's equals to 500. Anyway, I didn't even have to go and calculate it because they told me there that the random sample is 500. I should have known that the total is 500. Now they're asking, what is the percentage of A and C? A and C has 160, so I will say 160 divided by the total, which is 500, and that will give me my percentage. 160 divided by 500, and that will give me 0.3. 332. So when they ask you about the relative frequency, they will be asking you to give it as a percentage, or they can ask you to give it as a decimal, because on here the answer is 0.32, which is your relative frequencies. And if it was a percentage, then you will multiply this by 100 and your answer will be, so this will be a relative frequency, and for a percentage you will do the multiply by 100 and that will give you 32%. Sorry, not 35, but 32%. Okay, and that they might ask you in the exam. Okay, the other method of visualizing a categorical data is what we call a bar chart. So if you look at the bottom there, we have a bar chart, and a bar chart is just a bars which represent your categories, and the height of the bar represent the frequency, and sometimes they use the percentage as well. So the bars, these are your categories. The height represents your frequency or your percentage. And that is the basic you need to know about the visualizing categorical data. And the other property you need to know is the bar chart has spaces in between because the bars will never touch. So there are spaces in between for the bar chart. The other type of visualization or graph that you can create is a pie chart. And a pie chart is broken into slices, and the slices represent your category, and the size of your slices, they represent your percentage, and sometimes they can represent your frequency or count. Like I said, you don't even have to worry about what the Pareto is, but the Pareto, in case in future you just want to know, is just a numerical plus a categorical data. But when we look at the numerical values, it is just the cumulative values of this categorical data. So we just use the cumulative value to show how they add up to 100. And that creates what we call a Pareto chart. Okay, another exercise. Which one of the following graphical representation can be used to display a qualitative data? We know from what we just did, we know that it can be a qualitative data can be in a frequency table, pie chart, or a bar chart. So let's look here. It says histogram. We never talk about histogram. Yes, we did talk about the pie chart. I don't know what that. We never spoke about scatter plot. We never spoke about an OGIF. We never spoke about a frequency polygon. But we introduced the concept of frequency polygon with a Pareto, but we never said it is a frequency polygon. So the correct answer will be a pie chart. Okay, so now let's look at how do we visualize numerical values. Visualizing numerical values, we need to create what we call an ordered array, which means we need to sort the data from lowest value to highest value. We also can use the ordered array to create what we call a frequency distribution and a cumulative distribution table. So with an ordered array, we are able to create what we call a stem and leaf plot, which gives you the distribution of your data. A frequency distribution, it's like your summary table for numerical data. It will also give you the frequencies, and it also gives you the percentages, but it looks almost exactly the same as a frequency table, but this is meant for numerical data. And once we have a frequency distribution table, we can create what we call a histogram from the data that we have summarized. We can also create what we call a frequency polygon, or we can create a cumulative frequency polygon, which we call an OGIF. Okay, I'll go through this quick as well. So an ordered array is a way of organizing the data from lowest to highest. So you rank your data in that manner, from lowest to highest. So it makes it easier to also see your data points. Like, for example, here I have the day students. I can see the age of those day students, and quickly I can browse through. Sometimes using a table is not easy to recognize the patterns, but I can see there we have two 20-year-olds, we have 3 18-year-olds, and so forth. And if I look at the night school, I can see that at night we start with the youngest during the night student, it's 18 years, whereas in the day it was 16, but I can see that the highest one, or the oldest person in that group, was 45, whereas in the day it was 42. And I can see that this looks smaller than the average or your day students, but it doesn't give you much. So we can take this data and visualize it in a different way, which we can use a stem and leaf plot. Okay, so with the ordered array as well, it helps you to see where your range is. So the range is just taking your highest value minus your lowest value. So you can take your highest value minus your lowest value, it will give you what the range is. And it also helps you to identify if there are any outliers. But it might be very difficult to identify those, because if, for example, we have a 5-year-old in day school, therefore it means we have a problem there. There is an outlier. We cannot have somebody who is 5 years old at the college. Or we have somebody who is 96 years old at the college, but these days we do have those, so we need to investigate what that outlier is all about and fix the data if it's a data problem. Okay, so like I said, it's always not easy to check or to analyze data in the table, but we can use visualization. So for a numerical data, we use what we call a stem and leaf plot, which organizes the data into groups. And these groups are called the stems. So, for example, with the data that we just looked at, the first digit of that data that we looked at, if I go back to all these first digits, which are the first numbers, we call them the stem. And each stem is related to the leaves. So the leaves are those values presiding there, the stem. And if I look at this, so 6, 7, 7, 18, 8, 8, 8 will be my leaf, but they all have the same stem. If I look at all this, so from 16 until 19, they have the same stem, which is 1. So they will all be grouped under 1 as my stem. So how do we draw this stem and leaf plot? To draw the stem and leaf plot using the same data that I was using there, we'll draw for day students and night students. So you will see there. So the first digit, remember it's ordered. So the first digit, we first put all the first digits on there. So we know that the first digit is 1 and 2 and 3 and 4, and we can put them there. And then now we're going to put all the leaves. Under 1, we put all the values, even when the value repeats itself. Even if it repeats itself 10 times, you're going to put it there 10 times. So let's say, for example, like the 8, 18, 18, 18. So we're going to put all 3 18s. When you read a stem and leaf plot, this is where the challenge comes. When you read a stem and leaf plot, because sometimes in the exam, they might ask you to tell them what is the lowest value. When they give you the stem and leaf, they might ask you what is the lowest value of this stem and leaf? What is the highest value? What is the second most highest value? What is this? What is that? You need to know that to read this, you must also include the stem and the leaf when you are interpreting the information. You cannot say it's 6, it's 7, it's 7. So we're going to say it's 16, 17, it's 17, 18, like that. 19, like when you read for 2, it will be 20, 21, 22. So you always include the leaf as well and the stem together. So for the night, you can see there, and I can see that both my night and day students are very skewed. And this one shows me that it's like left skewed because the tail is to the, sorry, it's right skewed because the tail is to the right. And this one, the tail actually is not that bad, but it also is skewed, right skewed because the tail is to the right as well. Okay, and that is visualizing numerical data that is in an ordered array by using a stem and leaf plot. So now, in the exam, you will find questions like this, or even in your assignment where they say, you now understand what the stem and leaf plot is. So here they just give you at random. They say we have a stem and leaf display that describes 2 digits, which means the digits start from 20 and 80. So if I go back to that, the digits start from 80, so 20 and 80, it looks like this. So they will be saying it starts from 16 to 42. It means one and the same thing. So you need to use your imagination. For one of the classes displayed, the row appears as 5 is my stem, and then my leaves are 2, 4, and 6, which means then what is this in terms of the data? So now you need to decipher this. You need to unpack this and write it as a number. Like, for example, they give you the stem and leaf and they want you to write it as a table. And that's what they are asking you. So to write that, you will say this is 52, and this is 54, and that is 56. If I look at the data here, I must look for the one that looks exactly the same, and so I can put end there. So I can see that it's option number 3. And that's how you use the stemmed leaf, or you unpack your stemmed leaf so that you understand what it means. Okay. The other type of questions that they might ask you when it comes to a stemmed leaf diagram is this. Like I explained when I did that, what is the highest number, what is the lowest number? At the moment, because we didn't do the mean and the median, I am going to let it slide. I cannot ask you to do this exercise now, but when you do the practices and you go through your assignment as well, and you see questions like this, then you will know how to answer them. So for example, here they gave you the stemmed leaf plot, and they are asking you, which one of the following statement is correct? The range is 0. So we know what the range is. The range, remember, we discussed this. The range is your highest value minus your lowest value. What is my highest value here? My highest value will be the last point of the stemmed leaf here, and my lowest will be my first point of my leaf there. So my highest will be 86 minus my lowest is 36. And that will give you 86 minus 36, and that will give you 50. And that is your range. What is my fifth largest value? So my fifth, so I must start from the bottom and read the values up until I get my fifth value. So 1, 2, 3, 4, 5. My fifth value should be 8. So my fifth value here should be 8, because that's my fifth number on the table. There are 32 numbers. Now here is a challenge because I have to go and read each one of them. So you have to read, count the leaves, only the leaves, not the stem. You don't include the stem, but only the leaves. So you say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. Did I miss something? I don't know. I counted so quick. So I'm going to double check myself because I was counting very quick. 3 at the top, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. Okay, I counted right. So there are 33 values here, not 32. I'm looking for the correct answer. Remember that? That's what we're looking for. And then it says the mode is 0 and 5. So we're going to discuss the mode on Saturday. Do I leave it for Saturday? Okay, because I need to find the answer for this question. The mode is the most appearing number, the number that appears more than the other numbers. So if I look at this, scan, 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 zeros appears 3 times. So but this is 70, 70, 70. If I look at this, it says the mode is 0 and it's 5. I'm just going to say no, because that is, it should say it's 70, 70, 70, 70. So the mode should be 70 here, because only 70 appears 3 times if I look at this. So the mode here is 70. That's the number that appears more than the rest. Then it also asks, the median is 64. Oh, Gosia. The median, I need to find the position of the median, which is the middle number. The median, the middle number, we use the position n plus 1 divide by 2 to find the median position. So our n is 33 plus 1 divide by 2. So it will be 33 plus 1, and I'm going to divide this answer equals and divide by 2, and I get it's 17. So I can start from the bottom or I can start at the top to count the values. So I'm only going to use also the leaves. So I must get to 17 because it said the position. So I must put it here. This is a position. We're going to deal with this in detail on Saturday. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. The mean is 64 because I must also include the leaf when I decode the values. So that is the correct one. As you can see, this is what trouble you will get into in the exam as well. You will have to go through each statement and you need to understand how to calculate each one of them using the stem and leaf plot. Okay, so now let's look at other method of summarizing the data, which is, and I can see that we are running out of time as well now, but no problem, we will be done just now. So we can use also the frequency distribution table. And also, for example, your data needs to be ordered. So I'm using ordered data here. In the assignment or in the exam, your data will not be ordered. So you will need to sort your data. You need to first, before you do anything, arrange your data from the lowest or smallest value to your highest value. So mine, I've already sorted it. So I can see my lowest is 12 and my highest is that. The first step of creating a frequency distribution table is to calculate the range. We dealt with the range, highest minus lowest, 58 minus 12, which is 46. Then we select the number of classes. We select 5 because we don't want, we can see that this is not a big data set, so they are only 20, so we can select 5. It's best to select the lowest values because then you also want to create smaller classes because those classes, they will end up becoming your bar. They will look exactly, if you create a histogram, they will look exactly like a bar chart. And you don't want to have a bar chart that has so many bars, which has so many little, which is flat. You want to create the one that looks nice. And then 5 is usually the right one to select. So we select the 5 classes and then we compute the interval. And the interval is how big the class should be. How many numbers are we going to accommodate in a class? So as you can see there, we have so many, so little. So in this instance, it says it's going to create a 10 different class because we say the width, we say we take the range and divide it by the classes. You will say, but then I'm saying here, round it up. If you calculate this, you will get 9.2 something, which defeats the logic of rounding offs. But in order to create nice and clearer classes, you will see why. I am rounding it up from the 9.2 something number to a 10 so that my classes have a clear distinction or a clear number that starts from and end with. So you will see just now what I mean by this. So now we use the class to define our intervals. So we can look at the data and determine our first class by just looking at the data and say, but our class here starts with 12. So we can start with 10. And then we add 10, then we can end at 20. So we can say from 10 until 20 because our interval should just only contain 10 values in there. So we start from 10 and then we add the 10, then it's 20, and then the next one starts. So it doesn't include 20, but it has to be less than 20. Then the next one will start at 20, but it does not include 30, and then so forth and so forth and so forth and so forth and so forth. Then now, once we have created all our classes, we can then start assigning all these data points into each class. So we start counting each and every one of them and putting them there. So we say those that falls in between 10 but less than 20, we go and say 1, 2, 3. 21 is above, so there are only 3, and then we record the 3 there. Then we also go and say those that are between 20 but less than 30, we go 1, 2, 3, 4, 5, 6. Does not include 30, so this 30 won't be included, so there are only 6 there. And then you do the same for all of the values until you recorded all of them. And when you add them up, the same amount should be the same as the value that they recorded there. They should be exactly the same. There shouldn't be anyone who's missing. Then we can calculate the percentage by saying 3 divided by 20 gives you 15. 6 divided by 20 gives you 30, and you do the same for the whole table. Now, what do we use this for? How do we interpret some of this? Because you might be asked in the exam to interpret some of these questions, some of these values as well. But before we interpret those values, you can also create, or they can ask you to also create the cumulative frequency. What the cumulative frequencies are. At the beginning, we know that those that are less than 30 will also be the same as the frequency, so they are 30. But those that are less than 30 will include those that are more than 10 but less than 30. So it will be 3 plus 9, 3 plus 6, that will give you 9. And those that are less than 40, it will be 3 plus 6 plus 5 will give you 14. Those that are less than 50, you do the same. And when you get to the last boundary or the last class, the value you get from there, it should be the same as the value that you get from there. So it should be 20 because it's the sum of all of them. The cumulative frequency as well. So you will just say 3 divided by 20, it will give you 15%. 9 divided by 20, it will give you 45. Or you can add the cumulative frequencies per every class, and it will the last class will be equals to 100% as the same as your frequency. Now, how do we then, in the exam, when they ask you a question, they might ask you a question like, how many days were less than, the temperature was less than 50? So when they ask you in that manner, it means everyone or every day that was less than 50, it will include all the previous classes as well. So you can come to the cumulative frequency and say there were 18. And if they ask you what was the cumulative percentage, and then you can say it was 90. If they ask you how many temperatures were between 20 but less than 30, you just come to the frequency and say there were 6. If they say in terms of percentage, you say there were 30. And that's how you will answer those questions. And how do you interpret your frequency distribution table? So when you have a frequency distribution table, this is one of an example that I just used now. So here they're asking you, what is the frequency for the class 10 less than 15? So you go here, you look at the class less than 10, 15. But if we look at the heading there, it is a cumulative frequency. Therefore, if this is a cumulative frequency, then it means in this cumulative frequency, it includes as well those 15. So all what you do is you say, to find the frequency, you will say 21 minus 15, and that will give you the actual frequency for 10 less than 15, because 21 includes the 15. 21 minus 10 minus 15, 21 minus 15, then it will give you 6. And then you will know that that is the answer that you were looking for. And that's how you use a frequency table. So they might not give you the full table, but they will be asking you questions that relates to that table to answer. Okay, so once we have a frequency table, sorry, if you have any questions, I know that I'm chasing the Goddard 2 and I'm already on Goddard. If you have any questions, please stop me and ask the question. So the frequency histogram is it's a visualization of a numerical table based on the frequency distribution. And this is a bar chart for numerical values. So it's also called a bar chart of data, which uses the frequency distribution, but we call this a histogram. So if you look here, it's our frequency distribution table that we have. If we take our frequency or our classes, you can see that the bars will represent our classes and the height. In this instance, we're using the frequency, so the height represents the frequency. But now, the other thing you need to understand about the histogram, because we're using the class boundaries. So when one class finish, the other one immediately starts. When one finish, the other one sorry, the other one starts. And that is why there are no gaps in between, because when one starts, so these are the midpoints. So this will mean this is 10 to 20, 20 to 30, 30 to 40, 40, like that, to 50, and so on. So with the histogram, there are no gaps between the graph, and the the class boundaries are shown on the horizontal. So these are what we call the class boundaries. They are shown on the horizontal, and on the vertical side, we show either the frequency or the percentage. And those are the characteristics that, or the properties that you also need to know going into the exam as well, that makes up a histogram. Okay, when we have a histogram, we can also tell the shape of the data that we are looking at. So we can see that it's either symmetrical, it's uniform, or it's skewed, right skewed, or left skewed, or it is a bimodal data. And all this, it just gives you the summary or the description of the distribution of your data across. Okay, I was going to ask you to do this exercise, and since I am running out of time, I'm going to put this exercise on my UNISA or also on the WhatsApp. We can discuss it at the later stage, but I would prefer to put it on my UNISA as well, so that it becomes part of your exercises. Okay, so when we have a numerical, or what we call numerical summary table, which is the frequency distribution table, we can take from the frequency distribution table, we can create what we call the midpoint class, and then use those midpoint class and the frequencies to create what we call a frequency polygon. So the midpoints, which are those areas, at the beginning it will start with 0 because there is nothing in the midpoint 5, but at midpoint 15, which was our class boundary, remember it starts from 10 to 15. So at midpoint boundary 15, the midpoint, it was 3. So you can see that it relates to that frequency. And for 25, which is based on the class boundaries of 20 and less than 30, it was 6. And you can see the shape looks like that. So we use this, what we call a cumulative, sorry, I clicked. This is a frequency polygon or a percentage polygon, because we only use the percentages, and sometimes we can use the frequencies, and we call it the frequency polygon. When we use the cumulative values, then we change. We're no longer using the midpoint, but we use the lower class boundaries. So we take all the values of your lower boundaries, we create them as our indicator or on our horizontal variable. And then we calculate the cumulative frequency percentages based on the lowest boundaries. So you will see that it will start at the lowest boundary as 10. There won't be anything at 10 because there was nothing relating to 10, but there was something between 10 and 20. So that is why it's when we use the midpoints, now it makes it easier. But when we use the lowest class boundaries, then we won't have anything also for that one. So it will start at 10. And then when it goes to 20, remember at 20, there were other categories, so including 3, so it will be 15, and so forth. And this is what we call an OGIF, or what we call a frequency percentage polygon, or a cumulative frequency polygon, or an OGIF. It uses the cumulative percentages, and we can use it to compare groups of information with this. Okay, so when we do chapter 12, we will talk more about the scatter plot. So, but you must also know that a scatter plot is a visualization graph for numerical values. But here is not only for one numerical value, but for 2 numerical values. And we use this to check the relationship or to determine the relationship between 2 numerical values. So if you look here, we have the volume and the cost per day. And if we plot them, you will see that we can see the relationship that when the volumes bought per day, the cost also increases. When the volumes bought for per day increases, also the cost for a day also increases, which is very different. So this is the production volume, and these are your cost per day. But we will discuss the scatter plot in more details when we do chapter 12, when we look at the regression and the correlations. For now, I've been talking for almost 2 hours, so my throat is killing me. That's why we need to always have a break. And to do this final exercise, so the following techniques are applicable to a quantitative data. So we need to determine which one is applicable to a quantitative data. So we know that we use an ordered array. We know that we use a frequency distribution table. We know that we use a stem and leaf plot. We know that we can use a scatter plot, a scatter diagram, which is the scatter plot or the dot plot that we have. Therefore, it means all of the above. So which one of the following statement is applicable to quantitative data? So since we have selected all of the above, therefore we can select, we can say only E is correct because E says all of the above. And we know that all of the above, which is A, B, C, and D, are correct. So the answer will just be only E. And that's how you will, sorry, answer the questions in the exam or in your assignment as well. And that concludes what we were supposed to do. Usually this is only 1.5 hours, but because we started late, we ran into trouble there as well. So to recap on what we did today, we described what statistics is. We defined the key concepts of statistics. We looked at the types of variables that we use. We also looked at the different types or the different levels of measurements. And we also ended up looking at how we organize categorical data in terms of summary tables, pie chart, and bar chart, and how we organize and visualize numerical variables by using ordered arrays, frequency distributions, stem and leaf plot, a histogram, and a percentage polygon, and an OGIF. And that's all what we did today. And this is just a graphical indication of when we look at qualitative data, the types of qualitative data, the types of tables we can create. When we look at the graphical methods that relates to qualitative data, it's only bar chart and pie chart. When we look at the quantitative data, the tables, we can see that there are so many. We can create the frequency distribution, frequency relative distribution, the cumulative relative distribution, and so forth. When it comes to the graphical methods, we can use the dot plot, histogram. The dot plot is like your scatter plot. It means one and the same thing because we use dots. If you go back just 2 more slides, you can see that they look like almost dots. So we call it a dot plot, or you can call it a scatter plot. So we use a histogram, a stem and leaf, and an OGIF. And thank you, guys.